Okay, so let's review, first of all, really quickly where we were. We first tried to make a 3 by 3 pattern in a three-dimensional 3 by 3 by 3 volume spot. So I did that such that you can walk all the way around it. And then I did that with a 5 by 5, 6 by 6 by 6 area. And then I did it with colors over here. You can see I did it with colors so that it looks, a little different depending upon if you go look at it from this way to this way. So I wanted to see if there was any kind of a pattern to the coordinates. And so that's what I created on the left-hand side of this over here, is an Excel spreadsheet where the middle section right here, this section right here is the original viewpoint. And then this is what it looks like to the right. This is what it looks like to the left. This is what it looks like if I go all the way around to the back. This is the top up here, the viewpoint. And this down here is the bottom viewpoint. If you look up from the underneath of it. And so that was kind of neat. But then I looked at this and I saw something. So I wanted to try one more thing. And what I did was I then created something else completely besides that, except it wasn't completely different. I did it in a 5 by 5 area, and this is all the way over here. This is my original playground where I was looking for it. And so I created something. Let's see if you can see what it is from a distance here. A letter. In yellow letters, in the yellow blocks, I created an M. Okay, you can kind of see the M there. And so I got the coordinates of it, and then I thought, could I use my transformation equation to figure out what the viewpoints would be from this angle and this angle and the back of it. Notice it looks like an M from the back as well, a little bit of symmetry. And then from the top and bottom. Notice I did create a hole here so I could look up and see what it looked like from underneath of it. So I did this all in Excel. And so let me show you what it looks like over in Excel here now. Let me hit the big M. So this is what it looks like. You can see the yellow M right here. And the coordinates are underneath of all the points. Remember, the first one is the X, second one is Y, and the third one is Z, and positive is going away from us into further into the object. So instead of using 7 minus, I use 6 minus because this time it's a 5 by 5 structure. So that's where this, I don't know if you can zoom in on that spot right there. Let's see if it zooms in on that. No, stop that. So it's now, the equation is 6 minus x instead of 7 because we're in a 5 by 5 matrix now. So the complement of something would be 6 minus whatever the variable was. But you can see what this looks like, what this M looks like. Notice that if you look at this M from the behind, it does look the exact same going from this one to this one. But that wasn't what I was really excited about, because as I glanced at this, you can kind of see a little hint. I saw something, and I thought, if I were to shrink all of these together, and then take this M here and put it up top over there, I would have something that looks like a QR code. And that got me to thinking that this would be a really neat way to create your own QR code, where you're really only creating one three-dimensional thing of 5 by 5 by 5 or 8 by 8 by 8, let's say. That'd be a little bit more complicated, but it'd be fun. And not only could you do this with a binary, with black and white, you could also do it with colors, and you could create a colorful QR codes that would be opening things up even more for scanning and stuff. But just from one central object in the middle, you could create all the rest of the shapes and then create your own. But that's not what I really wanted to do. There's another little thing I want to do, and I'm gonna give it to you in the next one. I'll give you an example of what I want to look for. And that is, what if I were to give all of the other shapes except for the middle one? If I were to make something else completely, would someone be able to create what that middle shape is if they knew what the other shapes were looking at it from all the other angles. Could they recreate that object? So that's where we're headed. Again, this is just one application of this in mathematics. I thought it would be fun. If math isn't fun, I don't believe in doing it. And this kind of makes it a little bit more fun with coordinate geometry, three-dimensional coordinate geometry, and how things transform and can we predict it. And if I can get an Excel spreadsheet formula system, could I automatically recreate this based upon just one original structure? And that's where we're going. There's going to be maybe one more video after this, and then I'm going to end up this series. But then I'm very curious if anybody out there can take this further. Maybe this has been done before, and I'm not the first one to do this. I would really think that's possible, but you never know. I looked for it. I couldn't find it. So online, on any YouTube things, I don't even know what to call it. I called it three-dimensional blocking in Minecraft. I imagine there's something having to do with three-dimensional coordinates somewhere, but I doubt anybody has used Minecraft to explain it like this. I don't know. Maybe they have. I'm going to post this, and obviously the timestamp on my post will be there. But if anybody else finds something different before this, that'd be cool too. Maybe I could learn from them, and maybe you can expound upon what I'm doing here to make things even cooler. Maybe you have other ideas. But there we go. That's where I'm going with this. And there's maybe one other thing I want to play with too, but okay, I'll pause it now, and maybe you can get working on your own or comment underneath and let me know what you think. Okay.